Hi YouTube friends, I'm teacher Regy Safadão and today we're talking about the thermal expansion of gases. Are you ready? So, join us! Hi YouTube friends, this is our class number 6 of 6. This is our last class about thermology, thermodynamics today. Let's see our opening. As we already know, this is our channel of Mathematics Without Frontiers, and here we have classes of physics, mathematics and English in two versions, one in English and the other one in Portuguese. Go there, visit us. Our video classes in Portuguese are great. Go there. Let's see. As I told you before, now we are going to solve some questions about thermodynamics, thermal expansion of gases, all right? So let's see question number 1. Here it is, question 1. A latex balloon contains 3.1 cubic inches of certain gas at 90 Pascal. What will be the gas volume at 120 Pascal if the temperature remains constant? Okay, pay attention. This is just an illustrative picture, but if the temperature is constant, we are talking about what was given. V1, 3.1 cubic inches, P1, 90 Pascal, P2, 120 Pascal. And as I told you, what is required? V2, okay? And if the temperature remains constant, so the temperature is constant, we are talking about Boyle's law. What it states? Well, it states that the gas volume is inversely proportional to the pressure applied to it. So we are talking about an isothermic gas expansion. Why? Because the temperature is constant. So the formula, okay, Boyle's law says that P1 times V1 is P2 times V2 because the temperature is constant. So let's rewrite the formula up here. And we have V1, P1, P2, and we want to find V2, the final volume. So plug in the values into the formula. We have that P1 is 90, V1 is 3.1, P2 is 120. Okay, let me show you. I have here, I always forget this. So let me get a laser pointer. So I want to find V2 right here. So P1 is 90, V1 is 3.1, P2 is 120, and I want to find V2, all right? So let's do these calculations. 90 times 3.1, so it is 279. And now, see, I want to find V2. So I'm going to rotate the equation, okay? And while I do this, I already do the division because 120 is multiplying, so I can move it to the other side of the equation. And so, see, rotation. So V2 is 279 divided by 120. So V2 is 2.33 cubic inches, all right? So this question was about Boyle's law. Let's see question number 2. Here it is. So far, so good. Let's see question number 2. All right. A cylinder with a capacity of 80 liters contains gas at a temperature of 37 degrees Celsius. This container is heated to a temperature of 107 degrees Celsius while maintaining the pressure. So the pressure is constant. Calculate the new volume occupied by the gas. An illustrative picture of a cylinder. What was given? V1, 80 liters. T1, 37 degrees Celsius. T2, 107 degrees Celsius. Okay, pay attention to a very important thing. Well, V2 was required. Okay, so we are talking about Charles' law. Why? Because now we have a pressure constant pressure, in fact. Okay, so Charles' law states that the gas volume is directly proportional to the absolute temperature of the gas. We have an isobaric gas expansion. Why? Because the pressure is constant. So Charlie's law states that V1 over T1 is V2 over T2. So the pressure is constant. All right. So let's see. Oh, an important point. That's why it was written here in yellow, okay? Making you pay attention to that phrase. Absolute temperature. So these calculations were elaborated in the absolute temperature. So we have to use the absolute scale. Do you remember what is the absolute scale? Yes, it is Kelvin. So we cannot apply any of our exercises applying Celsius or Fahrenheit. We cannot. Every time the problem gives us Celsius or Fahrenheit temperature, we have to convert from Celsius or Fahrenheit, okay, into Kelvin. Every time we cannot use Celsius or Fahrenheit scales, okay? Very good. So remember, TK is TC plus 273. So let's do it. Okay, V1 over T1 is V2 over T2. Okay, so TK1 is 37 plus 273. So TK1 is 310 Kelvin, okay? And TK2, 107 plus 273. So TK2 is 380 Kelvin. Okay, now plug in into the formula. We have that V1 is 80. T1 in absolute temperature is 310. V2 I want to find. And 380 is the temperature in absolute Kelvin. All right. So see the way I used to do this. Now let's multiply like this. So 310 times V2 and, okay, it is 310 times V2 and 380 times 80, like this. You see? So let's multiply 380 times 80. So it gives us 30,400 divided by 310. Doing this division, I have that V2 is about 98.06 liters. Okay, so it was question number 2. We've done. Let's see question number 3. So far, so good. Let's see question number 3. Knowing that the total air pressure in a tidy was 3 atmosphere when the tidy temperature was 10 degrees Celsius. Celsius again, I have to convert. After running with this tire for some hours, it was found that its temperature rose to 45 degrees Celsius. The tire volume being constant, so volume constant, calculate its new pressure. Okay, so here I have a car tire. What was given? P1, T1, and T2, but temperatures were given in Celsius. I have to convert them. Do not forget about it. It's quite important. And what is required? P2. So we have here Gay-Lussac's law, okay? It states that the gas pressure is directly proportional to the absolute temperature of the gas. We have here an isochoric gas expansion, isochoric or isometric or isovolumetric. They are all the same, okay? So the volume is constant. So it means that the formula is P1 over T1 is P2 over T2, okay? Because the volume is constant. So let's see. TK is TC plus 273.15. Now the formula is a bit better. Okay, so P1 over T1 is P2 over T2. Let's convert. So TK1 is 10 plus 273.15 or 0.15. Doing this, I have that TK is 283.15 Kelvin. And TK2 is 45 plus 273.15. So TK2 is 318.15 Kelvin. These are the new temperatures, converted temperatures that I'm going to apply. So let's do it. So plug in the values in the formula. I have that 3 over 283.15 is P2 over 318.15. Now, let's multiply like this. You can see? Let's see again. You see? So I have that 283.15 times P2. I have it here. And now 318.15 times 3. You can see? So now let's multiply these values. And also, while I do the multiplication, I'm going to change 283.15 dividing. You can see? So 318.15 times 3 is 954.45 over 283.15. Okay, that was multiplied, now is dividing. Doing this division, I have that P2 is about 3.37 atmosphere. Okay, so question number 3 is done. Let's see question number 4. See, a given mass of oxygen gas occupies the volume of 12 liters at a pressure of 3 atmosphere and at 300 Kelvin. What volume will this mass of oxygen gas occupy when the temperature is 600 Kelvin and pressure 1 atmosphere? Okay, another illustrative picture. Given V1, P1, P2, T1, and T2. Now, what is required? V2. And so, let me move my window once again. Combined gas law. Well, it states that the ratio of the product of pressure and volume and temperature, pressure, volume, and temperature, PVT, of a gas remains constant. So our formula becomes like this. P1 times V1 over T1 is P2 times V2 over T2. This is the combined gas law. Okay, so let's rewrite the formula up here and let's plug the values in the formula, but don't forget we have to calculate V2. Okay, so plug in. I have that P1 is 3, V1 is 12, T1 is 300, P2 is 1, V2 I want to find, and T2 is 600. Okay, so let's do this multiplication right here now. So I have that 3 times 12 is 36. Now let's multiply in cross like this. Pay attention. So 300 times V2, it is 300 times V2, and 600 times 36. Here it is, you can see. And so it is 21,600. Now 300 is going to be moved to the right side of the equation dividing. So V2 is 21,600 over 300. And so V2 is 72 liters. All right. So it was our question number 4. But okay, let's see question number 5. Here it is. Let's finish. This is our last question. A 10-liter pressure cooker contains 2 liters of water and is taken to the fire. At thermoequilibrium, the amount of water steam that fills the remaining space is 0.5 mole. The safety valve is adjusted so that the internal pressure does not exceed 6.4 atmosphere. Considering the water steam as an ideal gas and disregarding the small volume of water transformed into steam, calculate the temperature inside it. So we have to calculate the temperature inside the pressure cooker. All right, here we have an illustrated picture, as always. Oh yes, we are talking about the general gas equation. It is the equation of an hypothetical ideal gas. So P times V is N times R times T. Well, P is the pressure, V volume, N number of moles, R the ideal gas constant, and T the absolute temperature. Don't forget, we cannot use Celsius, neither Fahrenheit, only Kelvin. All right. Okay, so what was given in our problem. Volume, 10 liters minus 2 liters. Why? Because the capacity of this pressure cooker is 10 liters, but 2 liters are already with water inside the pressure cooker. So the free space for air, okay, oxygen is only 8 liters, okay? So N is 0.5 mole, P is 6.4 atmosphere, and R, the ideal gas constant, is 0.082 atmospheres liter per mole Kelvin. So what is required? The temperature inside the pressure cooker, okay? Well, so let's see the formula once again. PV is nRT, okay? And plugging these values into the formula, we have that. 6.4 times 8 is 0.5 times 0.082 times T, the temperature. Now, doing these multiplications, we have here 6.4 times 8. Just 1 second. Let's get, once again, a laser pointer. Okay, so 6.4 times 8 and 0.5 times 0.082. So we have that. 51.2 and 0.041. Now, pay attention. The temperature is here, and I'm going to rotate the equation in order to get the variable T on the left. Okay, can you see? All right, so now I have that 51.2 divides 0.041. So the temperature inside the pressure cooker is about 1248.78 Kelvin, okay? Well, thank you very much, my friend. Let's see our special thanks. So thank you very much for watching our videos, especially watching the videos until the end, okay? Subscribe to our channel. It is quite very important for the increasement of this, all right? Share this video with everybody you love, your parents, your friends, your neighbors, your siblings, your classmates as well, okay? And of course, send us your like. It is really very important to us. Okay, I'm your teacher, Regy Safadão, talking to you from Brazil. Okay, well, thank you very much for watching. Have an excellent week. See you. Bye-bye.
That's all, folks.